Here we have the GSK 806, and Tony Schmidt is going to tell us a bit about this product.
We have it connected to our power supply, and then on the other side to an 18-volt electric motor. And so to get started, we'll turn our output on, set at 18 volts.
Where'd you get this electric motor?
I pulled it from an electric drill.
Cool.
And so we can start adjusting the pulse width modulation. So as we start to turn it up, there's quite a bit of torque in this. Right now we're in the first fixed frequency mode. But if I put the jumper here at J1 and put that in, we can now adjust our frequency. And so if you'll look on the oscilloscope, it's set at 600. I'll turn the pulse width up, and then we can start adjusting the frequency. And so we can go up to, let's say, 1 kilohertz. Somewhere right around there. We can adjust the pulse width more, higher. Get max revolutions. And move up and back down. Yeah, so the key features are going to be the ability to adjust the pulse width and the ability to adjust the frequency. First, it comes with a setting without the jumper right here, and so it's fixed at around 100 hertz. But once you put the jumper on, then you can change it anywhere from 400 all the way up to 4 kilohertz. Yeah, so these large heat sinks are going to help you really radiate that heat to get you a higher load. So this can output up to 30 amps. And so that's only possible because of these MOSFETs and these large heat sinks.
So is this really similar to what an electric car is doing?
I would say so. They're going to be on a much larger scale, but they're going to be using this basic fundamentals to start.